Assalamualaikum. First of all, I would like to say thanks to the Applied Zoological Society of Pakistan and Khaja Free University of Engineering and Information Technology to provide me opportunity to participate in the 5th International Conference on Applied Zoology 2022. And I am Kashif Manzoor, PhD scholar in Fisheries and Aquaculture in the Department of Fisheries and Aquaculture, University of Veterinary and Animal Sciences, Lahore. And the research title which I am going to present here is research work of my PhD degree, which I have submitted in a journal for PhD degree publication. And the research title is phenotypic, biochemical and molecular characterization of adverse Silatada and its prevalence in cultured tilapia species of fish farms of Punjab, Pakistan, and their post-mortem examination. And this research work under supervision of Dr. Fiaz Rasool, Associate Professor at University of Education, Faisalabad. And this is the table of contents which we will see in this presentation. First of all, we look some background of my research work. Idada is an emerging fish pathogen, a gram-negative bacterium and a facultatively intracellular pathogen. It spreads adverse. It causes massive mortality and huge economic loss in commercially important fish species. Increase in temperature causes high prevalence of Idada. Due to its transmission as zoonotic pathogen, Idada has also caused multiple infections in wide variety of reptiles, birds, amphibians, and mammals, including humans. Idada is an opportunistic pathogen and infects fish under environmental stress, low water quality, high temperature, high organic content, and high stocking density. Prevalence of Idada is also increased by multiple factors such as virulence and antimicrobial resistance genes. Morphological, biochemical, and physiological tests and molecular technique PCR are recently being used to identify and to detect Idada. Phylogenetic analysis is also used to compare its relationship with other bacterial species of its genus. Here these are objectives of my study. First one was to check prevalence of adversarial Idada in farm raised fish species, to identify Idada by morphological and biochemical test, to detect virulence genes and 16S rRNA gene of Idada by molecular technique. And hypothesis of my study was Idada may cause a virulent infection and massive mortality in tilapia species. And the statement of the problem was fisheries and aquaculture sector has been striving to provide disease-free and abundant fish to people all over the world. Idada is a zoonotic pathogen and causes adverse cirrhosis, which can also infect humans. Virulence gene of Idada causes serious infection and high mortality in wide variety of fish species. And I collected total 540 samples of 299 Orchinomis loticus, 138 of Orchinomis mozambicus, and 103 of Orchinomis aureus, from 12 fish farms of 3 districts of Punjab, Pakistan, and then I treated them with ice and transported to the laboratory of Department of Fisheries and Aquaculture, UAS Lahore. And I designed these fish farms of Kasur as FKS 1, 2, 3 and 4, that of Mandi Bahudin as FMB 5, 6, 7 and 8, that of Muzaffargarh were designed as FMG 9, 10, 11 and 12. And this table shows sampling of 3 species with respect to each district. This map showing study area of 12 fish farms of 3 districts. Sample fish was examined for external abnormalities and at the time of sampling, and internal abnormalities in infected fish in the laboratory. Swabs from 8 organs were inoculated onto triptych soya agar media plates using streak plate method to isolate etarda. These media plates were incubated at 37 degrees Celsius overnight and observed for bacterial growth. A single colony from this culture was inoculated onto brain heart infusion agar media plates to isolate pure culture of etarda. These media plates were kept in incubator at 37 degrees Celsius overnight, and etarda isolates from pure culture was stored at minus 20 degrees Celsius. A single etarda colony from freshly isolated pure culture of etarda was subjected to phenotypic and biochemical characterization. The DNA of etarda isolates was extracted using salting out method and Gentra pure gene DNA kit and quantified spectrophotometrically. The extracted DNA was sampled at minus 20 degrees Celsius. Etarda was detected by amplification of its sickness rRNA gene and GARP gene by PCR using universal primers and species specific primers. Respectively, PCR products were visualized in gel documentation operators to visualize bands of these genes. Purified DNA samples were sequenced by Sanger's method performed at BGI Hong Kong Company Limited, China. The obtained sequences of etarda isolates were analyzed and compared for taxonomic identification using NCBI BLAST and submitted at GenBank database. Phylogenetic relationship of etarda was checked by phylogenetic analysis of 16S rRNA gene by bootstrap method using MegaX. Descriptive statistics such as proportions and percentage were applied to summarize the data collected at the end of the study. A chi-square test of independence was applied to check cleverness of etarda with respect to organ of isolation, season, fish species and fish sex using SPSS. And now we look at results of my study. These figures show external abnormalities. First of all, this figure shows fin rot and skin loss, scale loss and skin depigmentation, skin lesions and hemorrhages. This figure shows exophthalmia in the areas of eyes, swollen abdomen and skin lesions, dark pigmentation, fin rot and corneal opacity, severe lesions and hemorrhages on head, vent and tail fin, enlarged liver and spleen with black dots and white bacteria filled nodules, gill rot and congestion, swollen abdomen with ascites having ascitic fluid and protruded and hemorrhagic anus. This is the figure showing culture of Itada on triptychs soy agar media plates having a round and circular with the grayish white colored colonies, and this figure shows pure culture of Itada on brain heart infusion agar media plate showing opaque translucent large irregular and whitish color colonies. And this table shows the phenotypic and biochemical characterization of Itada, and these figures shows bands of 16th rRNA gene on 1503 base pair size and that of garbage gene at 415 base pair size. Strains isolated in our study were having 99% similarity, but they also showed 99% similarity with Itada strains isolated in USA and 87% similarity with the Itada strain isolated in China and Korea. And this is the prevalence of Itada with respect to organs. Highly infected organ was recorded intestine, which showed 18.15% similar prevalence, and minimum prevalence was recorded in tail fin, which was 5.2%. This table shows the prevalence of garbage gene. Maximum was recorded in liver and intestine, 100%. And this shows prevalence of 16th rRNA gene, which was recorded maximum in liver, that was 100%. And this shows the prevalence of Itada with respect to fish species, and maximum prevalence was recorded in Orchinomis niloticus, which was 44.3% in the fish farms of Muzaffargarh. And this shows the prevalence of 16th rRNA gene and garbage gene with respect to fish species, and maximum prevalence was recorded in the Orchinomis niloticus, which shows 100% against garbage gene. And this shows the prevalence of Itada with respect to season. Maximum prevalence was recorded in summer, 44.6% in the fish farm of Muzaffargarh, and minimum prevalence was recorded in winter season in the fish farm of Kasur, that was 5.7%. And this shows the prevalence of Itada, 16th rRNA gene and garbage gene with respect to season, and this shows 93% prevalence in the summer season. And this table figure shows the prevalence of Itada with respect to fish farms, and the highest prevalence was recorded in the fish farm of Muzaffargarh. Designed was as FMG10, that was recorded as 37.7%, and minimum prevalence was recorded in the fish farm of Kasur, that were designed as ICAZ-1, 3 and 4, that was recorded as 20%. And this shows the prevalence of Itada with respect to fish sex, and maximum prevalence was recorded in male fish, that was 40.2% in the fish farm of Muzaffargarh, and minimum were recorded in the female fish, that was 19.5% in the fish farm of Kasur. And this table shows the prevalence of both target genes with respect to temperature and pH, and maximum prevalence of citrus gene was recorded 94%, and that of garbage gene 90% in the month of July at 37 degrees Celsius and at 6.67 pH. And this table shows statistical analysis result of chi-square of independence, and this shows that there were fish sex season organs and fish farms were showing insignificant difference, and that of district were showing significant difference. And this is the mortality. Highest mortality was recorded in the fish farm of Muzaffargarh, that was recorded as 7.7%, and Mandi Bahauddin 4.07%, and that of Kasur was 1.57%, and overall mortality was recorded as 7.69%, and maximum mortality was recorded in the month of July, that was 32.06%. And this is the final conclusion of my research work. Increase in temperature and decrease in pH favor high prevalence of Itada infection, adverse velocity, and massive mortality in under stress fish. There is no significant difference in prevalence of Itada with respect to fish sex, fish organs, and fish species, but its prevalence vary with respect to sampling sites to sites due to different environmental and farm management conditions. PCR is the fastest and easiest, more suitable method for detection of Itada. 16S RNA gene helps in comparing phylogenetic relationship of Itada with the different bacterial species of its genus and other genera. And thank you for your kind intention and for your precious time.